you folks also, of course, launched the infrastructure tenancy platform for AI, in part of this partnership. Talk about it. And also, if you can talk about, because you folks have built a lot of technology like private nodes, auto nodes, and a lot of other things are there. What are the building blocks of this platform?
So what we want to do, and as a community person myself, we want to capture the entire multi-tenancy spectrum space. So tenancy, the entire tenancy spectrum is now being covered by vCluster. That was the goal for 2025, and we were able to achieve that with the set of releases that we have done. Like you mentioned, previously vCluster was only shared nodes. So you have the control plane, and in that control plane, when you create a vCluster create demo, it spins up a stateful set, and when you create workloads, it still uses the host infrastructure. But now with the private node concept, what you can do is hosted control plane. So you can have the control plane pod still running on the host cluster, but when you join, you can actually join the physical nodes which are outside of the host cluster to those virtual clusters. Now this brings complete isolation, those who want maximum security, and a newer tenancy spectrum layer, that if you want the hosted control plane concept. And then we had auto nodes, Karpenter baked in. Nobody is able to do that. So vCluster is the only solution out there that provides Karpenter for bare metal, or Karpenter for any Kubernetes cluster out there.
Can you also talk about when it comes to GPU utilization, it becomes a big, utilization becomes a big barrier. How security can be a big issue, and that's where the, tenancy isolation comes up again. Can you talk about how is vCluster solving that problem?
That's a very excellent question. So let's say you have a bare metal setup. In the bare metal setup, you have a few CPU nodes and you have few GPU nodes. Now, traditionally, you will have various teams working and they would want their own Kubernetes clusters. So, and minimum you need 3 to 4 nodes for your Kubernetes cluster. So bare metal capacity is limited and you can't create that many Kubernetes cluster. So what we say is, combine everything, create a single Kubernetes cluster from your bare metal hardware with CPUs and GPUs, and then create virtual clusters and give that to your teams. Now, with the concept of private nodes and auto nodes, what you can do is, you can have one cluster and then a small cluster, and then in that you can have a virtual cluster control plane and enable auto nodes. Now, what it will do is, it will give you maximum security, plus it will, since the Karpenter integration is there for the bare metal as well, so it will use the free node for the particular virtual cluster, and if it's not being used, it will free that node out. So that's how the concept would really work, and GPU utilization will be the maximum in the bare metal kind of scenario. On top of that, if you even need more security, like you don't want privileged pod kind of access, then you can go for vNode. So with the whole data center would look like one cluster, virtual nodes, virtual clusters inside vNodes, and with auto node enabled.
Of course, everybody is on AI bandwagon, everybody is on, but just bringing another Kubernetes cluster to a GPU is not solving a lot of problems. How is vCluster kind of solving that problem? You did touch upon that, generally, but now you have an official partnership. How is it further solving that problem? That is not just another Kubernetes cluster that you are trying to build a Frankenstein monster there.
Yes, so the interesting thing is, when we talk about bare metal infrastructure, when we talk about GPUs, the GPU architectures that you get on the cloud and that you get when you buy directly from the NVIDIA, they are somewhat different in terms of the networking layers, in terms of how it works. So setting up those NVIDIA drivers and making sure the GPUs are available to be consumed by the pods is also challenging. And second thing is the schedulers. The regular Kubernetes scheduler is not that efficient in terms of the batch workloads or gang scheduling. So you need something like Kueue scheduler, or you might go for Run AI's own, NVIDIA's own Run AI that they acquired recently. So that kind of thing can natively work when you are using vCluster. So you can use vCluster, then you can easily integrate Kueue scheduler, and with the DGX thing, we are making sure that everything pieces together, like you mentioned, building blocks coming together and making sure it works. And it's not just a Kubernetes cluster, but it's a Kubernetes cluster that can actually run and scale your AI workloads.